Yeah, so I'm from Blecon. We're building what's effectively cellular networks, but using Bluetooth Low Energy. So I'm guessing a bunch of you are familiar with things like LoRa or NB-IoT networks. We're using Bluetooth Low Energy. And it's very relevant to beacons and smart beacons. One of my early observations, so I worked at Arm a long time ago, and someone once told me, people are talking about asset tracking, what they really mean is visibility. And I think that's quite an interesting trend that people still think about assets in terms of asset tracking, but now that really is becoming visibility. So I just wanted to show you some of the trends we're seeing and how that seems to be playing out. So first of all, what are smart beacons? Let's start there. So I'm guessing most of you are familiar with, I guess, what we call classic beacons, so Bluetooth beacons. Some small device transmitting Bluetooth low energy advertising packets. You may have heard of things like iBeacon and Eddystone and things like that. They're picked up by some receiver, some sort of gateway. That means you kind of know where they are because you know where the gateway is. So you know where this little Bluetooth device is. And then some cloud backend goes, aha, I know where that thing is. So every time some piece of infrastructure, which might be in a warehouse, in a van, in wherever it might be, spots one of these things, you know basically where it is. And those things obviously get attached to pallets, or they're embedded in products and things like that. So kind of the opposite of the marketing approach of beacons, which was people walking near things with their phone and a beacon detecting, the phone detecting they were near a beacon and telling them, hey, Bob, you're near a store. Here's a promotion for you. The other way around, the beacon is what's effectively being used as a localization tool. So very much asset tracking as it was originally invented. You might have even seen it, these are everywhere. I think, Teresa, it was even in your Rolls-Royce first slide, right? There was a beacon on there. They get everywhere. And they really do get everywhere, right? So this is one of those things that in the consumer market you don't see. Maybe more so now things like AirTags and stuff have become popularized, Tile back in the day. But actually, if you look in the industry, the industrial application of these beacons is crazy. If you walked around with a Bluetooth scanner, you'd realize quite how prevalent these things are in all sorts of industries. So it's a massive, massive exploding market. Even though many people don't actually even know that this is going on, because knowing where things are is really important to a lot of companies, right? Anyway, so the market is going crazy, but these things, which were born 10 years ago or even longer, people have trying to push them past all the limits of what they were imagined for. This basic tracking ability. So there's a load of technical things. I won't dive too much into these, but actually these are limitations are based on the original idea. When these were conceived, it was a cool idea. It has gone way beyond where people imagined them being used. I think if you told people back in the day how many of these beacons would be out there, you'd have a lot of shocked people. But these things are just shouting. So there's no way to know that anyone has heard them. You can't really say much, and you have to keep saying the same thing because that's all this is. It's just something shouting, I'm here, and something be able to detect it. So that's actually quite limiting on what you can do on these devices. There's no real security because that wasn't really the focus of these things. It was about marketing to some people initially, and then more just saying I'm here. How scary can that be to say I'm here? But actually, when you start using these in more critical applications, you can imagine it does matter that you know that is a beacon that you think it is. You do want to be able to attest that it really is that thing. Or if it's sending you some data, you want to know that it can be encrypted and things like that. So you can see how these things, like many things, once they get used beyond what they were originally imagined, they're providing a lot of utility, but perhaps the technology hasn't quite caught up. And then there's a load of deployment challenges as well, which is mostly down to the fact that you can, if you don't hear their message, it's gone forever. So infrastructure has to be there to listen. Okay, and then the second thing is usually there's some sort of intervention that's necessary to go and change how they behave. Someone actually has to turn up and basically connect to them and change them. So yeah, there's all these sort of problems. But luckily, technology, if you look at over the same period, what's happened, this I just took an example. I've tried to do it to scale. This was some excellent PowerPoint engineering here. But this thing here is, one of a recent Bluetooth microcontroller, the sort of things that end up in these devices, that was released this year. And it costs about £1. But you can see it's incredibly tiny. It has a huge amount of processing power. This is like your old phone. It has all these security features in there that we were working on back at ARM when we were starting to introduce these types of microcontrollers. And this is the sort of technology that's now available to be embedded into the same device. It's not just something that can manage to shout a radio signal. It's a whacking great computer that can do all sorts of amazing processing. Costs about the same as it did 10 years ago, but yeah, it's a crazily powerful device. So luckily that has gone the right way. So what people are doing now is, well, they're sort of reinventing these devices. So from the outside, they look the same. They're still a small device, often battery powered, that is attached to something. But actually, they're starting to introduce two-way communication, like any other communication network you would almost take for granted. You want to know not only where it is in the world, but you want to know the time. Well, why is that useful? Well, if everything knows the time, you can log things and later reconcile to have full audit logs and all this sort of great stuff. You actually want security that's fit for the purpose people are using them for today, rather than how they were imagining them being used 10 years ago. And well, you saw this is a full-on computer now. This is has the potential to do all sorts of processing. So actually, the firmware is really advanced. So you have to think like, what does it take to develop advanced firmware, and what does it take to maintain it? And this is all being driven by the fact that there's this huge demand for data, right? That's what people want. So if you think back to the early days of, I just want to know about where it is in a crude system, actually, a lot of companies now have realized the value is in the data, more so than even gadgets of what you can enable a product to do. But if you understand how your product is being used, where it is, how you can improve your product, or how you can understand what your asset is doing, where it's been, things like that. That's where the real value is. So that's what's driving it. But what I thought it'd be interesting to do, so this sort of technology actually ends up in all sorts of things. But if we look at asset visibility, there's sort of three interesting things that we see, and this when customers are coming and talk to us, which kind of unlocks this way of enabling things, unlocks new possibilities. And it's quite interesting that across all sorts of different, industries or domains, these same rules seem to keep cropping up, or these same behaviors seem to crop up. So the first thing is, well, if these devices can now be full-on computers with a load of storage, and they can have a proper conversation with a network, you can actually do a lot more in terms of storing data and storing what an asset has actually experienced, let's say through a supply chain. So the sort of classic beacons, actually they just shout the current status. This is the current temperature. And if you're listening, you know what the current temperature is. Great. Maybe you know that it was a maximum temperature it's hit, or something like that. But if this is a computing device that can record things and then talk like as if it would be talking over a cellular network or something like that, well, it can start logging things as it goes through a supply chain. It can start detecting different things. It can use intelligence to spot, I don't know, this thing has been dropped. It's been left in the sun. When was it left in the sun? So actually what you're getting here is the ability to, it may not come at the time that it's happening, but effectively you get the full data in your database about the whole history of all your assets. And that allows you to do amazing things, because now you can spot trends. Now you can understand where interventions are necessary. What are the trends that are causing issues? How do you go and change the fundamental system these are going through to improve, let's say, your supply chain or something like that? And you can do it with less infrastructure, because you don't have to be everywhere listening all the time. You can, if something comes back to a warehouse, maybe that's where you suck up all the data of the history of this device, or this pallet, or this product, whatever it might be. So actually, with less infrastructure, you can get a lot more data, and that means you can learn a lot more about what's really going on. So you know whose insurance this is going to get claimed on, or who's the supplier that you need to go and have words with about their behaviours or something like that. We're using supply chain as the example here, but actually this is surprisingly applicable to all sorts of industries. And then a second one we're seeing quite commonly, again, because this can be an autonomous device that actually has agency itself. A normal beacon, it just transmits so that you can spot that it's there. Well, as these things get smarter, they can start to actually scan themselves. Well, that's quite interesting. Why is it interesting? We're learning this all the time as people realize how they can apply it in their areas. But there's two really common examples we see. So one is a device can scan and spot another beacon, and maybe that's in a fixed location. So there's no network coverage, it can't talk to anything, but it can see another device, and that device maybe represents a location. So you now have a very cheap way of tagging a location, which is actually how a lot of the beacon applications started themselves. It's just they weren't being spotted by other beacons. So now you can very cheaply put out little way markers and find where were things going and which things have they come into, they come near. So you get a very interesting sort of locationing-based topology that can be done in places, in areas where there's no network coverage. So it's really interesting. And then a second one we've seen is, and this one is a bit more complicated, but it's quite interesting. Well, actually, if things are traveling together, maybe you've seen this when AirTags, something is following you or something like that. If two devices are going together, they know they're with each other, and then one of them perhaps stops being with the others, but the other ones get home. Well, the one that got home can tell you about the thing that didn't get home, which is really quite interesting. So suddenly devices, you start getting to the probability theory, where things that do, achieve, going through a supply chain correctly, can now tell you about things that fell off the back of the lorry or went the wrong way or something like that. So suddenly they're sort of being cooperative in quite an interesting way. And we've seen quite a few different applications of that. Anyway, so yeah, if you can record locations and if you can record range incredibly low cost, this is a very interesting sort of topology we're seeing. So, and I guess the most interesting one is just that these things can do processing. So these beacons historically, everyone talks about it as temperature, humidity. It's quite boring actually, but these things, because they are full-on computers and have now connectivity infrastructure to be able to manage the realities of what it's like to be running complex software, they can be running proper software, they can be running algorithms, they can be running edge AI algorithms. Now, conceptually, a normal beacon could do that, but in reality, you need a managed system, you need communication, you need to be able to update the firmware, all this sort of stuff. So you actually end up with some very sophisticated options here. So I've chosen a few of the classic, what I call high bandwidth sensors, so things that generate a lot of data. So this is a microphone, this is a camera, this is an accelerometer, all being highly commoditized thanks to things like mobile phones. But you don't want to send all that data, so these devices can actually take this high bandwidth data, infer locally some much higher level information, and that's actually what they log or that's what they send. So what you're starting to see is some really quite sophisticated systems that are currently classified as almost incredibly simple systems. So you can kind of see where this ends up, and actually pushing sort of AI processing to the edge is very natural. Because processing scales much more easily than the physics of radio transmission. So as processing power becomes more and more efficient, which is what happens, actually the cost of doing processing on a device versus the cost of sending a piece of data, it's continually diverging. So you can end up doing incredibly complex things on these devices. Anyway, yeah, so you can see these three things, which I guess are in the world of beacons. We're just seeing lots of companies starting to apply these techniques, and I think that's going to change how people think about beacons, I guess. And very briefly, just to put it in context, like a wider context, because I think that's useful. So we're actually building a Bluetooth low energy network. So if you've come across AirTags, or you've come across a LoRa network, or you come across a cellular network, think the blurring of those things. So we run a network focused on Bluetooth low energy, but we're exploiting the fact that there's loads of Bluetooth devices out there, so they can be our cell towers. So actually, my phone in my pocket is a cell tower for this room. So this room has Blecon coverage, amazing. If you're walking around a warehouse with a barcode scanner, it's basically free to give coverage to that warehouse. So Bluetooth has this amazing property that it's in lots of devices that can be cell towers, but also the chips that actually go into the sensors or the products, they've been hugely commoditized thanks to the amazing economies of scale they've worked at. So that's what we're doing. And then, we find ourselves in lots of different types of applications. But if you look at this sort of smart beacon applications, what we're seeing is people wanting to tag assets, like you would expect, but they're doing a lot more. They're tracking, they're putting interesting sensors in there, trying to spot anomalies, they're trying to run algorithms on those things. So that's an example of a sort of something you tag on something. Actually, people are looking to track people. And that's for all sorts of reasons of trying to understand behaviors, how they can improve what people are doing. How do plans match reality and things like that? So that's quite interesting. That's those sorts of devices. And then this is something we actually did announce last week in Germany. We're supporting these sort of tiny modules. And this is the sort of thing where people are actually embedding beacons inside products. So the beacon is not the primary function. The product is the primary function. But having a beacon inside gives the product manufacturer huge amounts of information to improve the product, help the customer, things like that. So really, really interesting area. Hopefully that gives you a sort of an insight into what we've seen in this sort of asset visibility stuff. We actually did a little white paper on it a month or so ago. If you're interested, that's quite interesting to give you a sort of technical rundown. And then, we're next door if you've got other questions. But hopefully that gives you, an insight into some of the trends we're seeing in what seems like quite a stable and established thing, but actually is growing incredibly fast and becoming way more complex than you would have imagined. Yeah.